Hi everybody, and welcome to today's video where we are going to be looking at dilations. And dilations, of course, if you don't know, is when we are taking a shape and we are either growing the shape or we are shrinking the shape around a point of origin or around a center point. So one of the things that you do need to understand is that a center point in a dilation can change. It can be anywhere on a Cartesian plane, and that is going to determine what the shape is going to dilate towards, or the direction that the dilation is going to happen. So let's draw a shape here. Let's draw a just something simple like a rectangle, and we're going to draw it like this. Okay, so now what we have here is a rectangle, and we are going to label these points. We'll call that R, S, T, and we'll call that one L. Okay? So when we are doing this and dilating, there's a couple of things that we need to know first. We need to know what exactly is the scale factor that we are going to be dilating by. Are we going to be dilating larger, or are we going to be getting closer to our center point? So I've got two different scale factors up here. We're going to toss in some numbers here. We'll scale factor by 2 today, and we'll also scale factor by 1/2. So what we'll do here is in yellow, we will do a scale factor of 2, and I'll show you how that works right now. The first thing I need to notice is I need to know, where is my center point? Now, this is kind of confusing for a lot of kids. They often think that the center point is right here in the middle of the Cartesian plane, which is always 0, 0. But sometimes that center point can move, and it will move from time to time. So today what we're going to do is we are not going to use 0, 0 as our point of origin. We are going to use, let's say, let's keep it simple. Let's go just 1, -1. So we're going to put our center point right here. This is now center. And so when we look at it as center, this is now our new 0, 0. It is now our new point of origin. Now you might look at that and say, well, how is that even possible when it is not sitting at 0, 0? It is now sitting at over 1, -1. And that's because I've determined what the center point is going to be. So these numbers are just guidelines for me to determine what the distance is away from center. Okay, now that might make a little bit more sense in a second. So what we're going to do is we're going to grab yellow, and we are going to do some mathematical calculations to determine what is going to happen with this shape. So the first thing that I need to know is I need to know the distance of one of the points, one of the vertices on here. So I'm going to choose T because T is the closest to my center point. Now you don't have to choose the closest. I'm going to choose T because I want to. So if I look at the distance away from center, T is -1, -2, -3. So T is -3 from center, and then it is 1, 2, 3 away from center. So if I did this in a dotted line, it would look like this. It would go over 1, over 2, over 3, up 1, up 2, up 3, and then I'm there. So hopefully you can see that that's how that worked out. So that is my distance of T away from this center point. That matters. If I'm going by a scale factor of 2 here, what I want to do is I want to multiply or double the distance away from center. So if this is -3, 3, and I multiply this whole thing by 2, I am now going to be -6 and 6 away. So T is going to dilate over 6, 1, 2, 3, 4, 5, 6, and up 6, 1, 2, 3, 4, 5, and 6. This is now my new spot for T. It is now sitting at 5. Let's do L, because L is on the same line here, so I know x-axis x-axis, it's going to be slightly over, so this was 3, 4, 5, so L is -5, and then I know it's 3, because it's on the same line as what T is. multiply it by 2, and what I get is negative 10, comma 6. So let's go from center point, our new center, our origin. We're going to go negative 1, negative 2, negative 3, negative 4, negative 5, 6, 7, 8, 9, 10. And then we're going to go up 6. So 1, 2, 3, 4, 5, and 6. So right here, on the same axis as T, L is now translated there. And now there's a way that I can check and make sure that this works. If I take a look at the number of jumps between L and T here, I start here, I'm going 1 jump, 2 jump. So if I've doubled the amount of distance away from center, then I'm technically doubling the length of the line as well. So if I was here at 9, I'm going 1 jump, 2 jump, 3 jump, 4 jump, and it just so happens that this is here, this is here. This was 2 jumps, this is now 4. I know that I've dilated it correctly. So let's do S. S right here is going to be over negative 3, over negative 3, and then it's going up 1, up 2, up 3, up 4. So negative 3 and 4, times it by 2, and we end up with negative 6, comma 8. So I'm going to start here at my point of origin, and I'm dilating S. I'm going to go over 1, over 2, 3, 4, 5, 6, negative 6, and I'm going up 8. 1, 2, 3, 4, 5, 6, 7, 8. And that now becomes S. They are on the same axes. Now you could solve for R if you wanted to do the mathematical calculation, but you don't necessarily have to, because you know that R is going to be on the same axis as L and the same axis as S. So I'm just going to put the dot in there. And then I'm going to connect my dots. And you can see what I have here is I have dilated this twice the distance away from origin, from now center, which is 0, 0 here, and the rectangle itself is twice as big. Now there is also another thing that I can show you here. It's going to involve me drawing straight lines. Unfortunately, I don't have a ruler, so I'm going to draw this the best that I can, but I want you to notice something. If I start and draw diagonal lines through these points, you are going to notice that all of these dots or vertices are going to end up on a diagonal line away from center through the original. Okay? Watch what I mean. So if I take this here and I go through T and keep going through T, it's not the best diagonal line, but you can see that T and T are both on the same diagonal. The same thing if I go through S. Okay, now obviously if it was a straighter line it would look a little bit better, but again I don't have a ruler so I'm doing the best I can. I'm going to go through R, and I'm going to go through L. And you can see that all of those diagonal lines have a vertice attached to them now. So let's do pink. Let's go half, because I want you to see the relationship when we're shrinking the shape down as well, and really pay attention to these vertices and these diagonal lines, okay? Because they're going to come into play again. So let's start with T. If I look at T, I know that from center, we were negative 3, 3. Negative 3, 3. If I have that, so if I multiply it by 0.5, I'm at negative 1.5, 1.5. I'm going to go over 1.5 and up 1.5, and there's T, right on a diagonal line. Let's see if it works for L. Negative 5, 3 away from center. I'm going to have it, times it by 0.5. If I have that, I'm now negative 2.5, and this is now 1.5. Start at center, over 1, over 2.5, and then I'm going up 1.5. Up 1, up 1.5, right there. See the same with S. S was originally -3, 4. Let's have it. We are over -1.5, and we are up 2. It's going to fall on this line with T, so we're going to go over 1.5 and up 2. Up 1, up 2. And that becomes S. And then obviously you can see here that if I just put this here, this is now going to be half the size of what my original one was. So a couple things that you need to know as you're doing these dilations. You always need to know what the scale factor is going to be, and you also need to remember that you're always dilating away or toward the center point. And the center point can move. Obviously, if this center point was here, then the shape is not going to grow in this direction. The shape is then going to grow this way. So as we move the shape down, now it would grow that way. If I move the dot over here, the shape will grow that way. Okay, so center point will move. What I am going to do is I am going to do another video where I'm going to put the center point right inside of the shape, and you'll see how it dilates later on. That'll be a second video. What I would invite you to do is rewatch the video as needed. Comment down below if you have any questions or if anything didn't make sense, and I'll get back to you. Like, share, subscribe, and thanks very much for watching. This was Dilations. We'll catch you again next time. Thanks.